In the year 1901, a group of sponge divers were working off the coast of the Greek island of Antikythera when they came across something extraordinary, a Roman-era shipwreck filled with priceless artifacts. And among these treasures, one object stood out like a sore thumb, an ornately decorated bronze frame containing a complex array of interlocking gears. What the divers had found was the Antikythera mechanism, also known as the world's first analog computer. Hi everyone and welcome back to my channel. Today, we are going to take a deep dive into one of the greatest unsolved mysteries of the ancient world. As far as archaeological finds go, the Antikythera mechanism is pretty much in a class all its own. Since its discovery over 120 years ago, experts have slowly begun to uncover its secrets, revealing an astonishing level of scientific knowledge and technological sophistication in the hands of ancient Greek engineers, machinists, and astronomers some 2,000 years ago. In fact, the Antikythera mechanism is so advanced that it makes scientists wonder if there might be more to the story, whether the ancient Greeks could have possessed a level of engineering prowess thought to have taken another 1,500 years to develop. So what exactly was the Antikythera mechanism, and how does it challenge our understanding of ancient Greek science? Let's find out. The Antikythera mechanism is a collection of more than 30 finely crafted bronze gears enclosed within a wooden box decorated with scenes from Greek mythology. It was built around 100 BC during the reign of the Roman general Pompey the Great and was named after the Greek island where it was discovered. But the mechanism itself was crafted in Athens, making it technically the first analog computer ever built. According to researchers, the Antikythera mechanism was likely created by a group of astronomers and mathematicians who wanted to build a portable device to track the motion of celestial bodies in the sky. Using a series of dials and pointers, the machine could track the positions of the Sun and Moon, as well as the 5 known planets, including Mercury, Venus, Mars, Jupiter, and Saturn. It could also predict solar and lunar eclipses using a technique called the Saros cycle, which remains in use by astronomers today. But perhaps the most impressive feature of the Antikythera mechanism was its ability to count down to the Olympic Games, which took place every 4 years in ancient Greece. This suggests that the machine may have had a cultural as well as scientific purpose. In other words, it may have been used not just to calculate astronomical positions, but also to keep track of important dates on the ancient Greek calendar. Now, while this is fascinating stuff, there's a lot that scientists still don't understand about the Antikythera mechanism. For example, we don't know exactly how the machine was powered, though it's believed that a hand crank on the side was used to wind up the mechanism. We also don't know exactly how accurate the predictions made by the Antikythera mechanism were, nor do we know how long it took the ancient Greeks to develop such a sophisticated piece of technology. However, we do know that the Antikythera mechanism was crafted at a time when Greece was a cultural melting pot, a hub of intellectual and scientific activity where ideas from around the Mediterranean were brought together and shared. In fact, many historians believe that the Antikythera mechanism represents the culmination of centuries of scientific progress in Greece, building on the work of earlier astronomers like Pythagoras and Euclid. But here's the thing. The Antikythera mechanism is so advanced that it makes scientists wonder if there might be more to the story. For example, the gear system on the Antikythera mechanism is so precise that it rivals the clocks of 18th century Europe, more than 1,800 years later. Not only that, but the inscriptions on the mechanism suggest that it was not just a tool for astronomers, but also a teaching aid used by Greek philosophers to explain their theories about the universe. And yet, despite its complexity, the Antikythera mechanism was somehow lost for nearly 2,000 years, only to be rediscovered by chance in a shipwreck off the coast of a small Greek island. This raises a number of questions. How did the ancient Greek engineers of the Antikythera mechanism possess such advanced mechanical knowledge? Why was the device lost for so many centuries? And is there more to the story that we don't know about? So let's start by addressing the first question. How did the ancient Greek engineers of the Antikythera mechanism possess such advanced mechanical knowledge? Well, the answer, to be honest, is not entirely clear, but let's consider this. In the ancient world, trade routes stretched across vast distances, connecting merchants, scholars, and engineers from Greece to China. And this exchange of goods and ideas would have exposed the ancient Greeks to new technologies and ways of thinking that were outside their own culture. For example, there's evidence that the ancient Greeks were familiar with Indian numerals and the Hindu system of astronomy. This could have helped them develop more accurate ways of measuring time and tracking the movement of celestial bodies. Additionally, the ancient Greeks were known to be fascinated by the natural world around them. They observed the patterns of the stars and planets with great interest and sought to understand the underlying principles that govern their motion. This scientific curiosity, combined with their exposure to new ideas and technologies through trade and cultural exchange, may have provided the ancient Greeks with the knowledge and tools necessary to develop such an advanced piece of technology as the Antikythera mechanism. But then why was the device lost for nearly 2,000 years? Well, one possibility is that the Antikythera mechanism was simply forgotten about. After the fall of the Roman Empire, Europe descended into a period of intellectual darkness known as the Dark Ages, which lasted from the 5th to the 10th century AD. During this time, scientific progress stalled, and many ancient texts and artifacts were lost or destroyed. It's possible that the Antikythera mechanism was misplaced or broken up during this tumultuous period, only to be rediscovered centuries later. Another possibility is that the Antikythera mechanism was deliberately hidden or destroyed. Some historians believe that the ancient Greeks feared that their advanced technology would be misused or misunderstood by others. In particular, there was a fear that the mechanism's ability to predict eclipses would be used to deceive or manipulate people. If that was the case, it is possible that the Antikythera mechanism was deliberately hidden away to prevent it from falling into the wrong hands. Is there more to the story? Well, that's a tough one. Many scientists and historians are skeptical that the ancient Greeks could have developed such an advanced piece of technology without outside help. They argue that the Antikythera mechanism is simply too sophisticated to have been created in complete isolation. However, other experts argue that the Antikythera mechanism is evidence of a high level of scientific and technological sophistication in the ancient world, and they reject the idea that the Greeks needed outside help to develop such a device. Indeed, recent research has shown that the Antikythera mechanism was likely crafted in Greece using locally sourced materials. Additionally, scientists have been able to recreate parts of the Antikythera mechanism using techniques and tools that were available in ancient Greece. This suggests that the device may have been created using only the scientific and technological knowledge available at the time. Now, I know what you must be thinking. What does this all mean for our understanding of the ancient world? Well, to be honest, the Antikythera mechanism continues to baffle scientists and historians to this day. Its discovery has forced us to reevaluate our understanding of ancient Greek science and technology, and it has raised more questions than it has answered. Perhaps the most important lesson we can learn from the Antikythera mechanism is that we should never underestimate the ingenuity and creativity of the human mind. The ancient Greeks were able to create one of the most advanced pieces of technology for their time using only the tools and knowledge available to them. This serves as a reminder that scientific progress is not always linear, and that even in the most seemingly backward times, there can be remarkable bursts of innovation. Ultimately, the Antikythera mechanism is a testament to the enduring power of human curiosity and the endless quest to understand the world around us. No matter how much we learn about the device, there is always more to discover and more questions to answer. And that is why the Antikythera mechanism will continue to captivate scientists and historians for generations to come. Chapter 4. The Mystery of Knowledge Lost. There are two big questions when it comes to the orrery. First, how did they make something so complicated in the first place? And second, why did this technology not just become widespread? There are lots of potential answers to these questions, but let's start with the leading theories. We can assume that it was the work of a single brilliant engineer or a small circle of advanced scientists who lived in Greece around 200 BC. One theory says that it was created in Archimedes' school. He was a mathematician, inventor, engineer, and astronomer who was born in Syracuse, Italy. In fact, there is some evidence that points to this because many of the surviving copies of his works were found near Syracuse. So it's pretty likely that that's where it came from. But the problem with Archimedes, he died in 12 BC, and all the orreries that we know of are dated after that. But maybe it was actually finished by his students after he died. Or maybe he had a secret student that survived the Roman conquest of Syracuse and passed down the knowledge to future generations. Well, either way, if it was connected to Archimedes, it's pretty cool. Like he is responsible for some of the most important discoveries in mathematics and physics, and he even invented the world's first analog computer. His engineering skills were definitely impressive. But we need to remember that this is speculation. There is no solid evidence proving that it was him or his students. But if you want to hear more theories, I'll leave some links below because there are some really interesting ones. Now let's move on to the second question. Why didn't this technology continue to spread? The answer is probably related to the first. After Alexander the Great's death, the Greek city-states started to lose their independence when Rome began to expand into the Mediterranean. The political climate was very unstable. The burning of the Great Library of Alexandria was probably the worst. It was one of the largest and most comprehensive collections of knowledge in the ancient world. But now only fragments remain. Even worse, during the Second Macedonian War, Rome and Greece went to war and Greece lost. This caused massive devastation across the region. And in 146 BC, Rome sacked Corinth, destroying its library and killing or enslaving thousands. Basically, this was a dark period for scientific advancement in general. But here's a lesser-known fact. The idea of an orrery might not have been unique to Archimedes or his school. You see, there are some vague descriptions of a similar device in ancient texts by Cicero and other Roman writers. So it's possible that multiple engineers independently developed the same idea. Maybe it was a common next step for someone who studies astronomy. Unfortunately, all those texts were written after the fall of the great libraries, so none of them contain any instructions or detailed diagrams. And now we come to the end of Chapter 4. In the next chapter, we will talk about modern analysis of the orrery and some new discoveries. Before we move on, let me remind you that you can support me through memberships. There are some really cool perks like the ability to vote on the next topic. So consider joining today. Also, be sure to join my community server. I post updates and interact with fans. It's a lot of fun, so consider joining today. Thank you for your support. Chapter 5: Modern Analysis and Simulation. Now that archaeologists have a complete set of fragments, we can analyze the orrery in ways we never could before. That's how in the early 2000s, researchers used X-ray computed tomography scans to look inside the device without having to break it apart. These scans revealed two things. First, there are several inscriptions on the fragments, which gave us insight into how the machine works. And second, there are gears inside the mechanism that nobody knew about. We now know that the orrery has at least 30 different parts, and some of them are quite complex. This makes it one of the most sophisticated pieces of engineering ever created during antiquity. In 2006, a team of computer scientists and engineers at the University of Athens used historical records and the fragments to build a replica of the orrery. Their replica looks almost identical to the original, and it works almost exactly as intended. Researchers are still debating whether the device was purely astronomical or if it was also used for navigation and calendars. But we don't know for sure, but here's another lesser-known fact. In the 2020s, researchers used artificial intelligence to study the orrery. By analyzing images of fragmented inscriptions, the AI identified patterns that the human eye could not perceive. This allowed researchers to partially decode the text and learn more about the inner workings of the device. And now we come to the end of Chapter 5. In the next chapter, we will talk about the implications that this discovery had on our understanding of history. Before we move on, let me remind you that you can support me through memberships. There are some really cool perks like the ability to vote on the next topic. So consider joining today. Also, be sure to join my community server. I post updates and interact with fans. It's a lot of fun, so consider joining today. Thank you for your support. Chapter 6: Implications for Human History. The Antikythera mechanism changed our understanding of science and technology during antiquity. For a long time, we assumed that mechanical computation was not possible until the Industrial Revolution. But now we know that advanced engineering was possible in antiquity. We just don't know why it disappeared. Think about it. The orrery was created at a time when the scientific community was making tremendous progress. It was a period known as the Hellenistic Age. It lasted from around 323 BC to the beginning of the Roman Empire in 27 BC. It was a period when Greek culture and ideas were spread throughout the Mediterranean. And this included scientific ideas, there were observatories, and some pretty advanced instruments. But then suddenly everything stopped, so we need to rethink our understanding of history. We always thought that technological progress was a straight line from the earliest tools to the agricultural revolution, to the industrial revolution, and then to the digital revolution. But the truth is more complicated. Humanity's scientific timeline is not linear. Instead, it looks more like a coral reef with lots of nooks, crannies, breakthroughs, and losses. Sometimes nature takes a step back. The orrery shows that it's possible to make extremely sophisticated devices out of basic materials. It also shows that knowledge can be lost, and this isn't just about the orrery. Every archaeological discovery tells us something about the people who made it, like their beliefs, values, and knowledge. The discovery of the orrery teaches us that even a highly advanced civilization can collapse. And it raises a very scary question: what if we are experiencing our own civilization's collapse right now? As we speak, there are entire industries dedicated to burying knowledge. People are paid large sums of money to hide facts, obscure data, and prevent the public from learning the truth. You can't make a decision if you don't know the facts. So it's important to be aware of what's going on. This brings us back to the orrery. What else may have been lost to history? What other knowledge do we need to recover? And now we come to the end of Chapter 6, but before we go, I'd like to thank my supporters. Without your help, this project would not be possible. I appreciate every single one of you. And if you enjoyed this video, please hit the like button. It really helps the channel grow. Thanks for watching. Goodbye.